In the field of statistics, there are several important concepts that help researchers analyze data and draw conclusions. Among these, the distinctions between population and sample, t-test and z-test, and chi-square and Pearson's are crucial for properly conducting and interpreting statistical analyses. Understanding these differences allows researchers to choose the correct methods for their data and ensures accurate results. Population and sample. The terms population and sample refer to two different groups in statistical research, each with distinct roles in the process of data analysis. A population refers to the entire group of individuals or items that a researcher is interested in studying. It is the complete set from which data can be collected. For example, if a researcher is interested in studying the academic performance of all high school students in a country, the population would be every high school student in that country. On the other hand, a sample is a smaller, manageable subset of the population selected for study. Researchers often choose a sample when it is impractical or impossible to collect data from the entire population. The goal is for the sample to represent the population as closely as possible. For instance, a researcher might select 500 high school students from various schools within a country as a sample to study academic performance. By using the sample, researchers can make inferences about the population, assuming the sample is representative. T-test and z-test. Both t-tests and z-tests are statistical methods used to test hypotheses and determine whether there is a significant difference between groups. However, they are used in different circumstances based on the sample size and whether the population standard deviation is known. A z-test is typically used when the sample size is large, usually over 30, and the population standard deviation is known. The z-test compares the sample mean to the population mean and helps determine if the difference between them is statistically significant. It is commonly used in situations where data follows a normal distribution and the parameters of the population are well established. In contrast, a t-test is used when the sample size is small, typically under 30, or when the population standard deviation is unknown. Instead of using the population standard deviation, the t-test uses the sample's standard deviation to estimate the variability. The t-test is particularly useful in situations where there is limited data and is often applied in experiments where the sample is randomly selected from a larger population. The t-distribution, which is used in the t-test, accounts for the increased variability in smaller sample sizes, making it more appropriate for these scenarios. In summary, the z-test is more appropriate for larger samples with known population parameters, while the t-test is used for smaller samples or when the population standard deviation is unknown. Chi-square and Pearson's are. The chi-square test and Pearson's are both used to assess relationships between variables, but they differ in the type of data they analyze and the specific hypothesis they test. A chi-square test is a non-parametric test used to determine if there is a significant association between two categorical variables. It compares the observed frequencies of data in different categories to the frequencies expected based on a hypothesis. For example, a chi-square test might be used to test whether there is an association between gender, male or female, and preference for a particular type of music, classical, rock, pop. The chi-square statistic helps assess whether any differences between observed and expected frequencies are due to chance or represent a true relationship. In contrast, Pearson's R is a parametric test that measures the strength and direction of a linear relationship between two continuous variables. It is used to assess the degree of correlation between two variables. For example, Pearson's R could be used to examine the relationship between hours studied and exam scores. The value of Pearson's R ranges from -1 to +1, where -1 indicates a perfect negative correlation, +1 indicates a perfect positive correlation, and 0 indicates no correlation. This test assumes that both variables are measured on an interval or ratio scale, and that the relationship between them is linear. To summarize, the chi-square test is used for categorical data to assess associations between variables, while Pearson's R is used for continuous data to measure the strength of a linear relationship between variables. Conclusion. In conclusion, understanding the distinctions between population and sample, t-test and z-test, and chi-square and Pearson's R is fundamental for conducting sound statistical analysis. A population encompasses the entire group of interest, while a sample is a smaller subset used for analysis. The choice between a t-test and z-test depends on factors such as sample size and knowledge of the population's parameters. Lastly, chi-square tests and Pearson's R both assess relationships between variables, but they apply to different types of data and examine distinct kinds of relationships. Mastery of these concepts is essential for selecting the appropriate statistical methods and making valid inferences from data.